So in this example, instead of having one set of objects that is together, we actually have two objects that are apart and they come together in a collision. So football game, we have a fullback, mass 108 kg, running at 9.1 meters per second, is tackled head-on by a defensive back whose mass is 91 kg, running at 6.3 meters per second. What's the speed of the pair just after collision? So again, we need to define one of these as object 1 and object 2. I'm going to pick the fullback as object 1, so M1 would be 108 kg. The speed of that fullback would be V1, so 9.1 meters per second. Defensive back will be object 2, so M2 be 91 kg. And V2 would not be just 6.3 meters per second. This is why I've included the picture here, because we have the fullback who is running this way. Call it to the right, call it to the east, whichever direction you want. He is running that way. And the defensive back is running this way, in the opposite direction. So even though it's not explicitly stated, we do need to understand what's going on in the question so that V2 is actually in the opposite direction of V1. So we do need to make it negative. And what is the speed of the pair just after collision? Well, the other variables in this equation are V1 prime and V2 prime. Now, because these two hit and stick together, V1 prime is actually going to equal V2 prime, simply because they hit and they stick together. So this is our question mark. So going and looking at the equation, M1V1 plus M2V2 equal M1V1 prime plus M2V2 prime. Substituting in, M1's 108 kg, V1 9.1 meters per second, M2 91 kg, V2 negative 6.3 meters per second, equals M1, which is 108 kg. And since V1 prime and V2 prime will be equal, I am going to call both of those X, and I'll explain why in the next step. Going and calculating, on the left, 108 times 9.1 is 982.8. 91 times negative 6.3 is negative 573.3. And the reason we called V1 and V2 both X is so that we can solve for it and get down to one single variable. We'll end up with 199X here on the right. Combining on the left, we get 409.5 equals 199X. Divide both sides by 199. We'll need 2 sig figs on this. We get 2.0 meters per second. And the other thing that's important here is the direction. Looking back at the velocities that we had, we said that the fullback was going in the positive direction and the defensive back was going in the negative direction. So when these two collide, we do need to state somehow that they're still going in the direction of the running back. Now, there is no real nice way to say that unless we had gone back and defined one going east-west, but this is perfectly good as long as it's clear which direction these two are going after they collide.